Hey guys, welcome back. In the last video, we looked at limits as x approaches infinity. In this video, we're going to use the trig identities that we've learned with the limit, and we're going to apply it to these types of special problems. So the first one to remember is that the limit as x approaches 0 of sine x over x is equal to 1. We showed that by the Squeeze Theorem. And the limit as x approaches 0 of cosine x minus 1 over x is equal to 0. Now, I just want to note that if this was actually reversed, it would still be 1. And if this was reversed, it'll still be 0, okay? So let's apply these over here. Now, this guy here says the limit as x approaches 0 for sine 5x over x, okay? So let's see what we're going to do here. This guy, 5, is the angle. It's part of the angle of sine. So we can't really do anything here. We can't even like pull him out. So what we do is we say, okay, I see the division sign, and I know that if I multiply something on top and on the bottom by the same number, I don't change the value. So once you guys do that, you can just say, all right, these match just like this matched. In order for this to work, these guys have to match, okay? So then the limit as x approaches 0 for this would then be 1. But there's a 5 on the outside, so this is actually 5 times 1, which is 5. And that's how you do that limit. Some of you might say, wait, how in the world did you get that? Well, let me show you why this works, and I'm only going to show it one time, and then after that you guys are just going to accept it and move on. All right, so let me show you here. Okay, let's get this here. I got x approaches 0. Originally, before I put that 5 in that, let's leave the 5 in the 5. So what I'm going to do is I'm going to say let y equal 5x. Okay, great. So let y equals 5x. So what I have here now is 5 times sine y over y. And now over here I have the limit as x approaches 0, but we changed the variable to y. So by you putting x to be 0 here, we can solve for this y. So 5 times 0 is 0. So now y approaches 0. Now we have, remember, x is just an arbitrary variable, so it can be y, it could be theta, it could be anything. So now this is equal to 1 when the limit as y approaches 0 times the 5 on the outside. That's where we get the 5 from. So the shortcut is, in this case, in any case, it's going to be this guy over this guy before I put that red guy in here. So let me get rid of this. So the shortcut is, first thing you should always do is direct substitution. You're going to notice that it's 0 over 0. Then say, oh, that's that limit special identity for the limit of sine x over x. It's always going to be this guy here over this guy here. So in this case here, you should substitute 0. Once you substitute 0, sine of 0 is 0, 5 times 0 is 0. You get 0 over 0, then you should say, oh, that's that special person. Great. So the guy in front of this x here is a 1, and the guy in front of this x here is a 5. So this answer is actually 1/5. Now, some of you are probably saying, like, wait, how? Why? Well, let me go back then and take away those red pieces. This was the original. And now this 5 is not connected to, it's connected to the x, but it's not connected to the x where I can't get rid, like, factor it out. It's not part of the angle. So I can look at this here as 1/5 times sine x over x. In the previous problem, this was part of the angle. You're not allowed to take that out. So here, you're allowed to take it out. Well, I can apply this here. If you guys remember the limit property video that I had, you can just pull out this constant 1/5, apply the limit here. What is this? That's 1. 1/5 times 1 is 1/5. And that's how you basically do this. Once again, your answer is going to be 1 over 5. Now, what you need to do is first check that it's 0 over 0 before you do anything else, okay? So let's try this other problem. It's the same exact thing. Well, what do you think the answer is? Well, first, let me do direct substitution. If I do direct substitution, I get 0 on top, 0 on the bottom. That's great. 0 over 0 Okay, this is that sine one, and guess what, guys? It's 7/2. That's your answer. Now, some of you might say, wait, what? Well, I'm going to first finish this, and I'll go back and explain it. Same thing, when you plug in 0, you get 0/0, right? Sine of 0, 0, 5 times 0, 0. So what is this going to be? Well, the 3 and the 5 is the answer for this part here, and then there's a 4 on the outside. So it's 4 times 3/5, which is going to be 12/5. Okay, this guy here, well, I want the number that's in front of this x and the number that's in front of this x. So that's going to be 1/3, and then there's that 2 here. So it's actually 2/3. That's what the limit is. So some of you might say, wait, how? Okay, in this guy here, I have my answer to be 7/2. What you do is you say, okay, this 2 is not connect. I can separate them. I can say 1/2 sine 7x over x. Great, everybody agrees with that. Now what you can do is you can say, I need the angle to match with the x in the denominator, so I'm going to put a 7 there, and then I'll put a 7 here, right? Because you haven't changed the problem. Great. So now you have 7/2 sine 7x over 7x. Well, guys, if these two match, then the limit as x approaches 0 for sine of the things that match is 1. Therefore, it's 7/2 times 1, which is also this guy here, right? This guy right here, 7/2. You can follow the same procedure here, except for in this case, okay, you're going to now factor out the 4/5. You're left with sine 3x over x. You can't take out this 3 because it's an angle. So then what we're going to do is you're going to compensate by putting a 3 there, 3 there. This guy is going to be 1. This gives you 12/5. And then you could do the same thing for this. And that's how you do that. And finally, we are going to do 3 problems, and then we're going to be done. I have 2 of them right here, and then I'm going to put the last one up at the end. Okay, so what do we do here? Well, once again, if you guys remember, the tan of 0 is 0, and sine of 0 is 0. Great, we need to somehow clean this up. So I'm going to write this as 3x times sine x over cosine x, that's what tan is, times 1 over sine x, because that's the denominator. Anytime you have something in the denominator, it's 1 over. Great. So now what? This guy goes out with this guy. You're left with 3x over cosine x. Let's try substituting again. Well, you get a 0 on top. Do you guys know what cosine of 0 is? Great. It's 1. So it's not 0/0. So your final answer is 0. Okay? The only time you start using identities is if it's 0/0. So in this case here, it's 0/0. So I'm going to use some sort of like maneuver. So sine squared means I can rewrite you as sine x over x times sine x over 1. Well, apply this to him, you get 1. Apply this to him, sine x at 0 is 0. So you get 0. Had there been another x in the denominator, then you get a whole different answer, because then you would have put the x down here, and then it'll be 1 times 1, okay? So it has to be exactly the same thing in order for this to be 1. Our final problem is going to be the limit as, the limit as x approaches 0 of tan, let's do 5x, okay, over sine 2x. You get 0/0 when you do direct substitution. Pause the video if you need to. So then you get sine 5x over cosine 5x. That's what tan 5x is. Times 1 over sine 2x, and sine 2x is in the denominator. Great. Now you're probably saying to yourself, what can I do here? Well, I'm just going to add an x in the numerator and add an x in the denominator. Great. I'm going to actually even separate it more. So I'm going to go sine 5x over 1x times 1 over cosine 5x, which is this guy here, times x over sine 2x. Just remember that I put the x in the numerator and the denominator, so it doesn't change the problem. Great. Can everybody tell me what this is? Do you guys remember our quick rule? So it's just going to be the number in front of the x's. So that's just going to be 5. Let's leave the middle alone. Once again, I told you in the beginning of the video that it can also be flipped. So this is going to be 1/2. Now, do you remember what, if you plug in 0 for cosine of 0, guys, is 1 and not 0. So that's times 1. And so this is 5/2. Some of you might say, whoa, that's a 5, that's a 2. Yup, that works also. Have a great day.